There are moments in deep space exploration when the universe behaves exactly as our equations predict. Everything unfolds according to the physical laws written into textbooks and tested for generations. But every so often, something happens that refuses to fit the pattern. Moments that don't simply challenge our understanding of physics, but seem to stretch it, distort it, and leave behind questions with no easy answers. Voyager 1, the most distant human-made object ever launched, has spent nearly 5 decades drifting farther from Earth. It has crossed beyond the Sun's magnetic influence, passed through the heliosphere, and entered an environment so cold, hostile, and saturated with cosmic radiation that no engineer ever expected the spacecraft to survive there for long. Yet it continues to transmit. And recently, a series of unusual observations has reignited old debates among scientists and space enthusiasts alike. The signals were unlike anything engineers expected. They weren't ordinary background noise, familiar plasma oscillations, or routine fluctuations in the interstellar medium. Instead, they appeared surprisingly structured, repeating with patterns that sparked intense analysis. Imagine tossing a bottle into an endless ocean, believing it will drift forever without being seen. Then one day, something appears to have noticed it. Not necessarily answering, but leaving behind traces that make you wonder whether your message reached somewhere unexpected. That possibility is exactly what makes Voyager's latest mysteries so fascinating. Tonight, we follow the incredible journey of a spacecraft built in the 1970s, powered by aging plutonium generators and computers less powerful than a modern calculator, yet still exploring regions no human technology had ever reached before. Along the way we'll revisit Jupiter's violent storms, Saturn's majestic rings, the frozen giants Uranus and Neptune, and finally the strange frontier beyond our solar system where reality becomes far more complex than anyone imagined. Voyager 1 was never designed to become an interstellar explorer. When it launched in 1977, its objective was straightforward. Fly past Jupiter. Continue to Saturn. Capture images, collect scientific measurements, and eventually fall silent as its power slowly faded away. Instead, history took a different path. Using a rare planetary alignment that occurs only once every 175 years, Voyager gained enormous speed through gravity assists, transforming a relatively short planetary mission into humanity's longest-running exploration of deep space. Equipped with a 3.7-meter high-gain antenna, 16 tiny hydrazine thrusters, and radioisotope generators whose electrical output decreases a little every year, the spacecraft has survived far beyond its original life expectancy. Today it travels more than 155 astronomical units from the Sun, still communicating across unimaginable distances. Most of its original scientific instruments have already been shut down to conserve power, but the remaining systems continue collecting valuable data about a region humanity had never directly sampled before. Voyager has no artificial intelligence, no advanced autonomous navigation, and no modern computing hardware. Its memory is incredibly small by today's standards. Yet its remarkable reliability has allowed it to become one of the greatest engineering achievements in human history. It is no longer just a spacecraft. It has become our only direct observer inside a region where every new measurement forces scientists to rethink long-standing theories. Long before interstellar space, Voyager encountered its first great surprises while flying past Jupiter. The giant planet revealed storms larger than Earth, lightning vastly more powerful than anything found on our own world, volcanic eruptions on Io reaching hundreds of kilometers into space, and radiation belts so intense they pushed the spacecraft's instruments close to their design limits. These discoveries transformed our understanding of the largest planet in the solar system. Hidden within Jupiter's powerful magnetic environment were subtle variations in electromagnetic activity that scientists initially attributed to natural plasma interactions. Decades later, some researchers revisited those early datasets, wondering whether certain unexplained features deserved another look using modern analytical techniques. Whether those patterns were meaningful or simply limitations of earlier models remains an open question, but they remind us how much information can remain hidden inside old observations. Saturn marked Voyager 1's final planetary encounter. Its breathtaking rings revealed countless narrow structures shaped by gravity and orbital resonance, while Titan's thick atmosphere hinted at an alien world rich in complex chemistry. The close flyby permanently redirected Voyager out of the plane of the solar system. From that moment forward, there would be no more planets. Only darkness. The sunlight grew weaker. Communication delays became longer. Temperatures continued falling. The familiar environment of the planetary system slowly disappeared behind the spacecraft.